Hello everybody, this is Ihsan. Welcome to Has Started Brain Tumor Project Detection. So we have the data set, Masudini Brain Tumor MRI data set, which is a training and testing split to four categorical image data sets. You can see from my screen that we have already classified images of the tumor consisting and with what type of tumor consisting images classified as well. We first get the necessary libraries and then we download it directly from Kaggle, and then based off of there we put different labels to the data set, and then the training data set is the first one, testing data set is the second one, and we kind of like figure to see what is we explore the data, how much of each figure do we have. There we almost have like a equal number of testing and training data, and then we start doing our validation and training splitting part. So we have the train test splitting happening on this line, with the necessary libraries imported as this, and after that we get we do the same thing for testing to see if they are classified as expected with their classes next to each one of them, and then we put the images batch sizes to put our neural networks as 32, and then our for exception, the first model that we are going to use, we use the image sizes 299 and 299, and then we rescale each of these images, and then after that we get the data frames ready for each training sets. They get validated, and then we do the specific to see what is it look like for each one of them, for like 4 images, 4x4 for each category that we had, and then we put them into our base model, and our base model is exception model, and then we build up on top of that, and that kind of like we fix it with AdamX, and then after that we start doing our model fitting, which is epoch 5. We used GPU for this module. CPUs are kind of like slow, and after that we kind of like get our data graphed out, which is after 5 epochs we get the best data, and then after that we kind of like look for evaluating our training accuracy, which is 99%, and loss is almost less than 1%, and validation accuracy is almost the same, but it's just over 1% loss. Total loss is 4%. So yeah, and our confusion matrix is here, and as you can see we only had the prediction of 0, which is glyinoma, instead of meningioma 6 times on this class. After that we do the predictions, and then see how it predicts. As you can see, it's correct. It's 100% predicted glyinoma, which are already glyinoma because we're importing from glyinoma library. As you can see, they're correct. And then we because this is a big model, we start doing for another CNN model for our dataset. So for that we use different image size, same batch size, and then we rescale it, and then we add it to our both valid testing and training data, and then we do the sequential data, and then we have like 511, 12, 256, and 128 neural networks, and then 64 and 64 is the last type of nodes that we have, and then we flatten them out, and then we get the density by 256, and then we flatten the last output layer as 4. After that we train it. It's also like an expensive model. I'll add the GitHub link that you can use what I have trained if you don't have the GPU to train on. And after that we get the metrics and then see how it perform over the epochs, and then we predict it, and then we see how it performed. I did not run it again because I'm out of GPU, so I already have my model over here, and we save it here, and then we display it on our web app, which is here. I have like one explanation. We have the training exception model and the custom CNN. One is it's predicting almost all meningioma based off of the saliency, like what it's actually thinking of, like which pixels that's looking from the model. So and then we use Gemini to get the explanation. That's how we do our testing. We can add different files as well, and then see how they are predicting. I'll do the same one because I did not download the images onto my computer. Thanks to recents. Seems like we don't have it. And yeah, that's about it. Thank you very much for listening. Enjoy a great day. Have a nice rest of your day.